All right. So welcome everyone. We are starting. We're now starting week 5. Well, actually, this is week 4. We're starting week 4. So we've done weeks 1, 2, and 3. Now we're starting week 4. This is a 6-week program designed to help you go over the math skills and kind of jog your memory so that you'll work on your verbal skills as well so that you'll be able to pass the ASVAB, the Armed Forces qualifying test, and then go into the military. As always, it's important to make sure you're able to get into Canvas, make sure you're doing the quizzes, make sure you're doing all that stuff to be successful. You should have gotten a note from Lynette this afternoon. She's going to be our new mentor or coach, going to help you work through the deal with any issues with Canvas or anything, and make sure you're set up with that, march to success. And then I'll be your resource for math questions and all that kind of thing. So we've got 3 topics this week. So I hope you're taking notes. It's really important to take good notes. We've got factorials. We're going to do geometry. And then we're also going to do mean, median, mode. Oh, that's not, y'all know I can't spell when I'm doing this. Mode and range. Those 3 topics. 1, 2, 3. Encourage you to take notes. This is a good opportunity. Is it difficult for anyone to see my paper, or is that pretty visible right now? Just want to make sure. I might see if I can fix the lighting a little bit. There we go. I don't know if that actually fixed it, but hopefully it's easy for everyone to see my paper. So let's get started. So our first topic is going to be factorials. Now, this is kind of a math topic that's all off on its own. It's not really talked about too much. I'm going to turn the light on because I think it makes it easier to see the ink for some reason on the page. So factorials are a topic that's not really related to much else. It's just a kind of thing that ends up being on tests and that kind of thing. It's a factorial is when a number has an exclamation point after it. So factorial is when a number has an exclamation point after it, like 2 factorial. You say that 2 factorial, 3 factorial, 4 factorial. Now, what does that mean? It means we multiply it by all the numbers leading up to it. So 2 factorial is 1 times 2. It's 2. 3 factorial is 1 times 2 times 3. So 2 times 3 is 6. 4 factorial is 1 times 2 times 3 times 4. 6 times 4 is 24. 5 factorial is 1 times 2 times 3 times 4. Yeah, you're on top of it, Bernadette. Times 5 is 125. Good job. Good job on that. That's 5 factorial. So all it means is you see the number, when you see that exclamation point, you go 1, 2, 3, 4 all the way up to whatever number it is, and then multiply it by that. And these numbers get huge. Like we went from 2 to 6 to 24 to 125. 6 factorial is going to be really big. 1 times 2 times 3 times 4 times 5 times 6 equals that'd be 125 times 6, unless Bernadette beats me to it. I think that's 250. Did I multiply that in? No, that's definitely not 250. That's way more than that. Do that again. I try to do these fresh for you guys, not off of notes. So that 6 times 2 is 12. 750, that's right. Yeah. 12 plus 5. 6 plus 1 is 750. Yeah, so it's 750. So you see how massive these numbers get. And then the next one will be times 7. Now, what are some things we might do with factorials? like where will this actually come up when you're doing problems? Well, they may just ask you what is like 7 factorial, whatever. Fine, just got to go do it, got to write it out. But they might also do a problem like this: 6 factorial divided by 2 factorial. Actually, let's do 3 factorial for this one. So we could write this out: 3 times 2 times 1, and we could write out 6, 2 times 1 divided by 2 equals 3. That's easy enough for that one. But what if all of a sudden we get 6 times 6 divided by 3 factorial? All of a sudden we're getting really big numbers. We remember from up here that 750 divided by 6, but that's a big math problem. Here's the shortcut. If you're faced with a problem like that, you can say 6 factorial divided by 3 factorial, write it out: 6 times 5 times 3 times 2 times 1, 3 times 2 times 1. And then you can cross out something if it's on the top or the bottom. We can go, we can cross out 1, cross out 2, cross out 3. Sorry, I apologize. This should have a 4 right here. I left it out when I was going in order. So it should be 6 times 5 times 4 times 3 times 2 times 1. So we can cross out 1s, cross out 2s, cross out 3s. And now we have 6 times 5 times 4. That's a lot easier math problem than 750 divided by 6. So it's a lot better. So 5 times 4 is 20. 20 times 6 is 120. So that's the answer there. So if you get a division problem like that, you need to write it out and do cancellations, and that'll be so much easier than having to do all that long division and everything. Let's see, does anyone have any questions about that? That's really all there is that's going on right here. That little division trick, and then you're pretty set. The other ones, if they say multiplication or addition or subtraction, you just have to figure out the numbers. Like 6 factorial minus, let me make sure I'm on the page, minus 3 factorial. You're just going to have to come out to 750 minus 6 and then say that's 744. So you have to do that if it's 700 and you know what, I think we did this factorial wrong up here. Did we? I don't know, but Cordes, let me make sure I did the math right. Yeah, so 750 times 6. 750 minus 6 is 744. This is actually a problem on one of the quizzes. The reason I wanted to bring this up is the quiz does not have the correct answer on it. That happens sometimes with March to Success. The correct answer will be 744 on that one. That's number 3 on the quiz this week. So that's factorials. Let's look at geometry now. Let's go through geometry. Now, in all of this, we're going really fast through a lot of material, I realize. So I know that's difficult, and I appreciate you all always bearing with me. This one in particular is difficult because this is a whole year of school that people do this subject, geometry. So now I'm about to try to go through the most important things in one class here. First thing to know is, what is an angle? What is an angle? And geometry is just measuring shapes and measuring angles and stuff like that. So an angle is when 2 lines come together. It measures how close together they are, basically. And an angle can be from 0 to 360 degrees normally, is what an angle is going to be. If you have a circle, you can have an angle that's really little, like say that's 1 degree, or you could have an angle that's really big, like we can say that's 120 degrees. So an angle is a measure of how close together when 2 lines are intersecting, how close together it is. Let's look at how to find missing angles. This is going to be something they're going to test on. Finding missing angles. So let's say we have a right angle. And something I want you to know about right angles is this little box. When the two lines intersect and it's got this little box, it means it's a right angle. And a right angle equals 90 degrees. So right angle equals 90 degrees. So now let's say we got a right angle and we have an angle coming right through the middle of it. So the issue here is, well, it's not an issue, but the trick here is know that since a 90 degree, a right angle is always 90 degrees. All the angles that make up a right angle are going to be 90 degrees total. Let's demonstrate that. Let's say this one is 45 degrees. If this whole angle is 90 degrees, 90 degrees minus 45 degrees equals 45 degrees. That one's going to be 45 degrees as well. Let's do another right angle. Let's say that this is a right angle. Let's say this is 20 degrees. 90 degrees minus 20 degrees equals 70 degrees. This one here would be 70 degrees. I'll do one more. Let's say we have a right angle. And we have a 1 degree angle here. It's actually bigger than 1 degree angle, but for the purposes of this, it's 1 degree angle. This missing angle here would be 90 degrees minus 1 degree equals 89 degrees. So that's how you find the measurement of a missing right angle is you subtract 80 degrees from, or you subtract it, the one you know, from 90 degrees. Let's do another one. Or let's do another type of angle. Now let's do a straight line. So let's say we've got a line here. Then let's say it's 100, it's going to be 180 degrees. So this right here is 180 degrees. So if we have an angle here, let's say this angle is 60 degrees. To find the missing angle here, we'll go 180 degrees minus 60 degrees equals 120 degrees. So this one is 120. So straight line equals 180 degrees. And so these angles together, angles that add up to a straight line crash. You all there? Someone say something or indicate something if they're there. I get kicked out of Zoom on my Mac. Okay, you can hear me? Good. Okay, sorry about that. I don't know what happened. I saw myself frozen. Let me fix my paper and then we'll get, so I'm not sure exactly where I was. Let me kind of talk back about what I was doing for a minute. So when the angles add up on a straight line, add up to 180 degrees. So angles that add up to a straight line are called supplementary. Big fancy word for this big fancy class. Supplementary. Angles that up to straight line are called supplementary. Angles that add up to 90 degrees are called complementary. Complementary. So if somebody says I have a 30-degree angle, and what is the supplementary angle? You and I would say, as we run out of paper, 180 degrees minus 30 degrees equals 50 degrees, or sorry, 150 degrees. I'll see how good my mental math is right here. Next thing to think about and to know is, gotta get a new piece of paper, is let's talk about when we have lines that intersect each other. Let's say we have some beautiful lines that intersect like this. I'm going to call this A, this B, this C, this D. Angle B is equal to angle D. Angle A is equal to angle C. When they're across from each other like this, it means they're equal to each other. And you can kind of see, like if you look at it, you'll note and like start drawing intersecting lines like that, you'll notice that it just in a way kind of makes sense that they're it just kind of makes sense that they're the same. They look the same, don't they? So let's say we have lines like this. This one's 30 degrees, this one's 40. Let's say this one's 140 degrees. Well, we know this one's going to be 40 degrees because they're 140 degrees because they're opposite each other, and this one's going to be 30 degrees because they're opposite each other. And that's all there is. That's all there is to it. And actually, I'm going to make this be 40 degrees, and this one be 40 degrees because this is also a straight line. You see that straight line, 40 degrees, 140 degrees, 140 plus 40 degrees equals 180 degrees. So we can use this little trick. Isn't this like nifty? Just a little cheat code type thing. Let's say we have lines that look like this. And let's say all we know is this one is 120 degrees. Well, we know 120 plus or 180 minus 120 is 60 degrees. So we know this one's 60 degrees because here's the straight line. And so then we can do the crossways thing, 60, 120, so we can fill it in. I know you need that so much in your everyday life, filling in the angles when they're intersecting. Now you've got that valuable skill. Let's look now at sums of angles. We're still adding up. Like we've done 90 degrees, we've done 180 degrees. Remember, this is a right angle. This is a straight line. Now we're going to do triangles. So here's what you need to remember. The inside angles, that means angles right there, of a am I writing in all caps or lowercase? Let's see. Triangle. Now I'm not spelling right. Triangle, pretend like that says triangle. Equal 180 degrees. This is a law of the universe. It's always true. Never fails. Let's say we have a triangle and it has three equal angles. One is 60 degrees, the others are going to be 60 degrees, and this 60 plus 60 plus 60 equals 180. Let's say we have a triangle that looks like this. 50 degrees and 70 degrees. Now, how can we, and let's say this is A, called angle A, we're just naming it A. How can we find out how much angle A measures? Well, we go 180 minus 70 minus, so 180 minus 70 is 110, and then we subtract, put the degree signs. Then we subtract 50 from that. 110 minus 50 is 60 degrees. There we go. So now we know this one is 60 degrees. So the inside angles of a triangle always add up to equal 180 degrees. One more. I want you all to try this one on your own. And then after you try it, send me a DM like on in the chat, just a private message instead of to the whole class. Tell me what number you come up with. This one is 120 degrees. This one is 35 degrees. So try to work that on your own and tell me what this angle X is. So try to work that one on your own and then send me a message on Zoom. Tell me what it is. All right, let's see what we're getting. Okay. So this is 120 and this one is 35. So I have a vote. I have another vote. Okay, I've gotten 2 votes. Good. So let's see what the answer is. 180 degrees minus 120 degrees is 60 degrees. And now we have to subtract 35 degrees from that. 60 degrees minus 35 degrees. 10, 5, 5. So the answer is off the page or off the screen, 25 degrees. Beautiful, beautiful, beautiful. Let's talk about another shape. Now let's talk about a funny critter, a quadrilateral. Quadrilateral. Wow, that's a lot of letters. Quadrilateral. What I want you to remember is 4 sides, not quadrilateral. That's confusing, but 4 sides. So four-sided shapes. For these, the inside angles equal 360 degrees. Let's take the most simple one ever, a square or rectangle. We know these little boxes are 90 degrees. So 90, 90, 90, 90. 90 times 4 is 360 degrees. Very most simple one you can have. Let's say we have one that looks like this now, a little more complicated. So here that has these 2 little right angle symbols. When it has that, we know these are 90 degrees. And then it also has 110 degrees right here. So we say 360 minus 90. That's 270 degrees minus 90. That's 180 degrees minus 110. That is 60 degrees. So this one is 60 degrees. Let's look at this one. I'll do a really hard one. Why don't you guys try this one? I didn't draw that one correctly. So let's say this one is 77 degrees. Say this one is 35 degrees. Let's say this one is 123 degrees. I'm feeling really nice today, aren't I, giving you that one? So why don't you work that one out and similarly send me what you get. So what is this angle? We'll call this angle B. So I'll write it big, 123, 77, 35 are these inside angles. So why don't you work it out and send me what you come up with, okay? Okay, I've got one answer. Any more answers? Let's see, I've got some more popping up. Yeah, I got 2 more answers. Okay. Any more answer? I'll wait a little bit more. I've got them from half of you guys. All right, I'm about to go on. So this, for this one, all right, I'm getting some text now. You can do it several ways. You can go 360 minus, minus, minus. What I'm going to do is I'm going to add them up together. $200. Then I'm going to add this one to it, 235. And then once I'm added them, I'm going to subtract 360 minus 235. 10, 5, 5, 2, 1. So 125 is the answer. Good job. I think everyone got that. Everyone that sent me a message got that. So that's quadrilaterals, the missing one there. All right. Next one we're going to look at is perimeter. Perimeter. So this is how long around something. To find the perimeter, you add the sides. Add the sides equals perimeter. Say I have a desk. Say this desk I'm working at right now. Say this desk I'm working at right now is 4 feet long and 1 foot wide. Well, we know this one's also 4 feet. This one's 1 foot. So we go 1 plus 1 plus 4 plus 4, 8, 9, 10 feet is the perimeter. So you just add up the sides. That's all there is to perimeter. Really, I think as long as you know the name of, like, you know what, you recognize this word. I think as long as you recognize this word, you can do that part. Easy peasy, no problem. All right. Let's move on to area. Now, with perimeter, we were concerned about going around something, right? Now for area, we're concerned about what actually covers it, like what's inside. So area equals length Yeah, that's right, Bernadette. Good job. Times width. Good. So that's what area is. Sorry, I need to make sure that's visible for you guys. Let's look at a rectangle. Now let's say this one is 4 inches and this one's 3 inches. What's the area? You would say 3 times 4 equals 12. Now, one thing you have to do is you have to say squared when you do the area. Area, you always talk about in terms of squared. I got a message. Okay, got it. You always have to do it in terms of squared. Say it in terms of squared. So let's say we have a big field that's 80 yards and this one's 60 yards. Yard, we have to go 80 times 60. 0, 0, 0, 0, 48, 4,800 yards squared. So that's the answer. That's the answer for something like that if you want the area. Now, so these are like the nice normal shapes. Now let's say you have triangle. Area of a triangle. This is a little more difficult. A, or area, equals 1/2 times the base times the height. That's the area. So let's say we have one that looks like this. Let's say it's 5 on the base, 6 on the height. So we 6 times 5 equals 30. And then we say 30 times 1/2 equals 15. So 15, let's say inches squared. Now, when I multiplied by 1/2, we've done fractions. So it's like 30 times 1, 1 times 2. It's 30 divided by 2. When you multiply something by 1/2, it's the same as dividing it by 2. So you can really just say, you can also say base times height divided by 2, whatever is easier for you to remember. Let's say we have this fun triangle, 15 and 2. We say 1/2 times base times height. So we say 1/2 times 15 times 2 equals 30 divided by 2 equals 15. So this one's the same area. I just did them with very different looks. Let's do area of a circle. Fun topic. So you may have heard of a number called pi. Pi is a number that equals 3.1415926, and it goes on and on and on forever. If you want to like not join the army and just be a professional nerd, you can see how many digits of pi you can memorize. There are bizarrely contests where people do that. All you need to know really is pi is equal to 3.14. And they're probably not going to ask you to do any math where you're actually knowing that. Just remember, this is a funky number. It's represented by this Greek letter pi, and it's really important when we're doing geometry things. So the area of a circle, the formula for that is area equals pi times the radius squared. Area. Another way we write that is A equals pi r squared. Now, what is the radius of a circle? The radius is this line right here. If we go from the middle to the edge, this line is called a radius, and we measure the length of the radius. That's what we're measuring here. So let's say I have a circle, beautiful circle, right? Here's the middle of it. And let's say the radius is 2. So now we say the area equals pi r squared. So we know the area is pi times 2 squared. So we know 2 squared is 4, so 4 pi is the area. Let's try another one. Say we have a circle, and the radius is 6. So A equals pi r squared, A equals pi 6 squared, A equals 36 pi. Not too bad, is it? Now here are the trick problems. Here's where this comes in. Let's say they have one and they tell us the diameter. Sorry, I didn't write radius here. You should notice that, or try to notice that. That's important. There's the radius there, but now they give us all of a sudden diameter. Diameter is the line that goes from one edge to the other edge through the middle. So it's basically it's twice of the radius. So diameter equals 2r. 2 times the radius, 2 times radius. So if they tell us the diameter is 14, d equals 14, radius equals 7. So for the area of this one, we go A equals pi equals 49 pi. So you just got to know, you gotta remember that the diameter is twice of the radius. And remember, when I say 7 squared, that means 7 times 7. Or I say 6 squared, that means 6 times 6. Or I say 2 squared, that's 2 times 2. Let's do another area of a 3D figure. This is a lot of fun, this one. So let's now say they give us a box that looks like this. I'm a beautiful, beautiful artist. Museums ask me to put, if they can put my drawings in their museums all the time. Not really, because my drawings stink. Let's say we got a box that's 6 inches long, 3 inches high, and 2 inches wide. And we want the area. You got to just add all sides. So this is hard because you got to first figure out how many sides there are. There's 1, 2 here. There's 1, 2 here. And there's 1, 2 here. So there are 3 different kinds of sides and 2 of each of them. So the bottom and top are 6 times 2. Bottom and top. They're 12, and there's 2 of them. So those are 24. Now let's do the short sides. Short sides. Those are 2 times 3, or 3 times 2, same thing, 6. And there's 2 of those, so those are 12. Now let's do the long sides. Those are 6 times 3, equals 18. There's 2 of those. 18 times 18 is 36. So now finally we have to do 24 plus 36 plus 12. And that's because we're adding up all these sides. So when we add this, it's 12, 1, 5, 6, 7. I think that should be right. Let me do it in my head. 40, 20, 60, 70. Yep. So 72 is the area. That was a lot of work. Well, that's just how they are. Those are a lot of work. So that's finding the 3D the area of a 3D figure. You just got to add all the sides. Let's now talk about something lovely called volume. Volume. So we've had several things so far. Perimeter. We went around and we're concerned about how long around. Area, we measured how much, not mush, how much space inside. And then volume now. Volume. We're going to measure beautiful drawing, right? How much fits inside? So let's like think about what kind of things we would measure. Like this would be a length. So it would be like inches, feet, etc. This is like square feet. If you ever heard of a square foot. And then this volume, you could say cubic feet, but we also use a lot of other things. We use gallons. So things you measure in gallons or that you would measure in cups, that's what we're measuring our volume. We're measuring how much can fill up. Like I have some contact solution right here. I did not have this here for the purpose of this class. I just happened to. This has a volume, and the volume of this is, oh, there's my camera. Wow, that's hard. The volume of this is 2 fluid ounces. Fluid ounce is another measure of volume. So we have to find volumes, and volume equals area times height. So let's go back to this same little rectangle thing I had, or rectangular prism I had earlier. 6, 2, 3. Now we know we got to find the base area. 6 times 2 was 12, and we got to multiply it by the height. So 6 times 2 is area, height is 3. So 6 times 2 times 3 equals 36. So that's the volume there. One special circumstance, let's say we have a cylinder. I'm going to draw it down here. We know, and let's say the radius is 3. Well, we know how to find the area of a circle. Area equals pi r squared. So we know the area equals pi 3 squared. Area equals 9 pi. And I forgot to say the height here is going to be 10. So we say area times height. I'll try to write that out. Area times height equals 30. Brilliant, right? So we measure how much is in here by saying the area times the height. So that's volume. We're getting close. We're almost done tonight. Don't worry. I know this has been a lot of information tonight. Let's talk about circumference. Say we have a circle, and we want to know how far around it is. So in a way, it's like the perimeter. Well, the circumference equals d pi. Circumference equals diameter times pi. Sorry, I should write pi. Now, here's how I remember this. I remember Coke equals Dr. Pepper. C equals D P. Silly little thing. For some reason, it helps me remember it. But you got to remember circumference equals diameter times pi. Now remember, diameter equals 2 times radius. So say we have, so now we know circumference equals 2r pi. The circumference equals 2 times radius times pi. Let's say we got this circle and the diameter is 4. Well, we know C equals D P, or C equals diameter times pi, so circumference equals 4 pi. Say we got another circle, the radius is 5. We know circumference equals 2r pi. Circumference equals 2 times 5 times pi. Circumference equals 10 pi. Once you memorize these formulas, that's going to be so easy, and it's just you're going to blow through the ASVAB with those parts. Just like I'm blowing through like stacks of paper tonight as I write. One more topic to know, a really fun one, Pythagorean theorem. Pythagorean theorem. This says if we have a right triangle, which a right triangle means it has a right angle. You could have figured that out, I bet. One of them is 90 degrees. Let's call this side A, this side B. Somebody said something. Yeah, oh, that was a while ago. Sorry, I just noticed the chat. Yeah, okay, good. Sorry. Let's call this A, this B, this C. Well, A squared plus B squared equals C squared. That's kind of wild, right? So A squared plus B squared equals C squared. You can use that to find missing sides triangles. Let's say we know this triangle, this right triangle, it has 6 and 8. So what is side C? We know A squared plus B squared equals C squared. So A, B, 6 squared plus 8 squared equals C squared. 6 squared is 6 times 6 is 36. 8 times 8 is 64. So equals C squared. 36 plus 64 is 100. So we know 100 equals C squared. If you remember week 1, we talked about how we can reverse things. If we've got a square, we can reverse it by doing a square root. Square root is just the opposite of squaring something. So the opposite, 10 squared is 100. So the square root of 100 is 10 equals C. So 10 is C here. Let's say we've got one that looks like this. 12, 16. Oh. Yeah, sorry about that. I should be back now. I don't know why it did that. So let's say we got this triangle. This is A, this is B, this is C. A squared plus B squared equals C squared. We might be tempted to go 12 squared plus 16 squared equals C squared, but that's wrong. Don't do that. Because A, B, C, so A squared plus 12 squared equals 16 squared. So all of a sudden we have to do this. We got to say 12 times 12 is 144. 16 times 16. I'm actually going to have to do the math because I don't remember that off the top of my head. 96, 0. Then that should just be 16. 6, 5, 1, 256 equals 256. A squared. Now we're doing algebra. We have to move them from one side to the other. Minus 144, minus 144 goes away. A squared equals 112. So the square root of 112 equals the square root of A squared. And now this is, I don't think they'll do one this hard, but if I remember correctly, 11 times 11 equals 112. Let me confirm that real quick. Might have done them a minute. No, so it doesn't equal it. 11 times 11 is 121. Let me make sure I did that math real quick. 256 minus. Yeah. So if it doesn't come out to an even square root, we just have to say 112, square root of 112, and that's the answer there. All right, you guys are doing great. I had another topic tonight. I don't think it's going to take that long, so I'm going to try to do it real quick, so that you're able to do the homework. Mean, median, mode, and range. Yippee. So mean equals average equals sum of numbers divided by number of numbers. That's a really fun way of saying it, right? So my video so I can see, make sure I'm on the screen. Yeah. So one way I remember is the mean teacher averages my grade. That's one way I remember it. So the mean teacher averages my grade. The mean is the average, and that means you take all the numbers and add them up, and however many numbers there are, you find it out. So let's test this with, and then I'm going to give you the definitions actually. Mode, number that occurs most often. Median, number in the middle. Range is range equals largest number minus smallest number. So for these, let's do all these with this set. When you see these funny Batman wings, it just means like a group of numbers. 3, 1, 12, 5, 3. So let's first find the average. So first, to find the average, we have to add all these up. So remember, average equals is going to equal all of them added up. 3 plus 1 plus 12 plus 5 plus 3. And then how many numbers are there? There's 1, 2, 3, 4, 5. So divided by 5. So this math is kind of straightforward now. Just have to add everything up. So 3 plus 1 is 4, plus 12 is 16, plus 5 is 21, plus 3 is 24. I'm paranoid now after making a math mistake earlier that I'm going to add that on the calculator to confirm. That is 24. 24 divided by 5. So now all we have to do is all we need to do is do the division. 24 by 5. 5 goes into 24 4 times. 20. 4. 5 goes into 40 8 times. So 4.8 is the answer. That's the average. Let's find the median, the mode next. Well, I'll write them again. 3, 1, 5, 12, 3. I wrote them out of order. Oh well. Well, what number happens the most? It's 3. It happens twice. So mode equals 3. So let's find the median. Let's line them up in order. 1, 3, 3, 5, 12. And if a number occurs twice, when you're doing the median, you got to put it there twice. So we cross out the smallest, we cross out the biggest, cross out the smallest, cross out the biggest, and the median is 3. Finally, let's find the range. So you remember the make sure I'm still on the page. You'll remember the range is the largest number minus the smallest number. So we can say 12 minus 1 is 11. So 11 is the range because 12 and 1 are the biggest and smallest numbers. So that's mean, median, mode, and range. There's a whole quiz on that. If you can memorize the definitions, you might have to think and work out problems, but you're going to be all set. So thank you all for coming. I'm going to turn this video. So Jolise, you said you got me on the division. Is that on the average? Put a note in the chat. Yeah, okay, so let me go through that again. So just the division process. Let me get a fresh piece of paper. So I'm going to do different ones, so it's different numbers. 28 divided by 5. So we say, how many times does 5 go into 28? It goes in 5 times because 5 times 5 is 25. Bring that down. We subtract 8 minus 5 is 3. 2 minus 2 is 0. Now 5 doesn't go into 3, so we have to put a decimal here, add a 0. And then we bring the 0 down. 5 goes into 30 6 times, so we can put a 6 up here. There's 0. Now we bring the decimal up, and so the answer is 5.6. Hopefully that's more helpful for that kind of division problem. And it was the same process for 24 divided by 5.